Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Salvador who has completed the course ROS 2 Navigation. So what we will do is we'll first see him do a demonstration on the real robot, and we'll later get into the details about his project. So as we do towards the end, we will get to ask him a couple of questions to find out how exactly he managed to accomplish the task. I'll now hand over the platform to him so that he can begin his presentation. All right, Salvador.
Hi, how are you? Thank you very much. So I will just briefly finish setting up,
All right. You might
and
as well
then
take
we
us
will
through
go
what you're
straight
doing.
into the demo. Yes, okay, so what I'm doing right now is I'm just preparing the terminals, building all the files, turning on the ROS distro, and set up cache. Great. Okay. Now let's do the demo. So the first thing that I need to do is I need to turn on RBiz. Let's see, do I have it hidden? Is this gazebo or is this? Okay. And then I have a file here, which I've already configured, that's going to show sensors and map in the way that I want. Nice, very nice. And then we see that there's nothing here. That's because I have not made any of the map or the localization available yet. So I'm going to go ahead and launch that. So ROS2 launch project localization. I have a localization executable, and this launches the map node. And now the map is available to use.
Okay.
I'm going to use this controller to see if I can come up with an estimate of what the robot's position is. Looks like we're facing this way on this edge, so that's I think over here. No, over here. So what I'm going to do is I'm going to use this tool, and I'm going to initialize something like that. And the reason I like using this tool instead of doing it programmatically is because when we're doing these real robot interactions, people leave this robot in all kinds of locations. So it's just a lot more straightforward than trying to establish that we're somewhere with some kind of command.
All right.
Unless it was like a home. Okay, so we'll see here that we are not very well localized, and we see that this distribution of these red dots, let me make them yellow so that we can distinguish the laser from the particle filter. All right, these are the possible states that we could be in, and we see that they're very spread. There's a lot of uncertainty. So what I'm going to do, I'm going to just spin, because we have kind of a simple map, and that should help us converge on where we think we are.
Right.
To run teleop twist. Great. Turn down the speed, and then I'm just gonna rotate, and then we should watch as the program converges on where it believes it is. It's using something called adaptive Monte Carlo localization, which is comparing sensor data to map data, and it's using a probability distribution based off of Bayesian math to come up with this estimate of where it thinks the position is. And we see how all of these points, which were everywhere, are now starting to converge on where we expect to be, which is good because this is nice and focused.
Right.
Alrighty, so now that that's done, we're localized, so now I could do some path planning. So what I want to do is I'm going to move this over here. ROS2 launch path project path.
All right. Which terminal were you doing that in?
This is terminal 2.
All right.
So the first one I've done localization. Terminal 2, I've turned on the path planner.
Right.
And then now over here, this is where I'm going to send commands to run the script.
Okay.
So this is where I'm gonna. So first, I'm gonna go into where I have my map stored. We can see here that's this guy here. I'm sorry, not my map. The spots that I want to go to. So this is what I've named the file. and that's where I'm going to go. So what I'm going to do is I'm going to do ROS2 run. The package it's in is project pathfinding, planning. And the name of the executable that I've made is called movex. And then I'm going to give it the name of the point. We have the 3 points, which is corner 1, pedestrian, and corner 2. And I'm going to give it a command, and then we'll see how it does.
Okay, all right.
Params, file, HP, label, equals corner. Let's do corner 1. So right now we're here. We want to go over there. So let's. So it should accept the. I guess did I write my command wrong? RS2 run x ROS args params file p. I don't think I made a mistake with that. RS2 run project move x ROS args params file. Oh, I didn't put the name. Let's see, put dash p label. Corner 1. Okay, there we go. So it registers the request. We see the path that it is planning out. And then we can look over here and we can see the status from all of the different servers that are coming together to do path planning.
All right.
So when things are nice and good, we have the controller server, which is doing local planning for the small distance in front. And then look, very nice. Goal succeeded. That's very nice. But if there are other situations when there are obstacles, then there are a few other players in the game too that help make decisions on how to avoid and how to recover from being stuck or something like that.
Right.
So let's try this again, but instead of going to corner 1, let's go to corner 2, which is where we started from. All right, so goal is accepted. The controller sending this new path. It's really interesting to see how it calculates. See, differential robots are what's called non-holonomic. And I think the most intuitive way that people drive these things is in like this piecewise. I'll move a direct line, and then I'll do an arc, and then I'll move a direct line, and I'll move an arc.
Right.
But it's really interesting to see that the way that this plans it does not do that. And I really, really appreciate that because I actually have some experience in optimal control. Say it again?
It makes it difficult, the fact that your planner doesn't plan in a non-holonomic sense or in a differential robot sense in the context in which it thinks.
Yes and no. I'm just saying that I appreciate the depth, the complexity that goes into the fact that it's not doing that.
Right.
The fact that it's not doing straight line and turn and straight line and turn.
Right. Yes.
Because I do have experience in as we can see it succeeded, which is good. I interrupted myself, but I do have experience in optimal control for differential drive robots.
Right.
And doing the time optimization is a much more involved problem. Because I think the basis of even here, I'm still a little confused on parts, which is something I'd like to explore more on how you guys actually do these things. Admittedly, a lot of the files are kind of just given to you, and you have to connect the dots yourself. Yes, but as far as like building that up, the behavior tree, the controller, all of these things are kind of done for you.
Right.
Which lets us focus on the high level parts of this. But my background being in the controls makes me a little bit more interested and focused in how do I go and do this specific, how did you actually make your controller do this thing?
All right.
That's something I'd like to learn more about.
I see.
There's one last spot called pedestrian, which is over here. And let's see, it goes very nice. Cool. I like it. Yeah, so very straightforward. Again, all of these files are mostly, they kind of trivialize a lot of the small details so that we can focus on like the higher level picture, I think, of what navigation means. Um, and like I said earlier, I would like to explore more on the specifics. For
Right.
example, when they say optimal path, the way my professor introduced it, was very different from my like controls background version of optimality.
Right.
He had like this cost map, this 2D plane of like based off of location. And yeah, intermediate state error is definitely something that is a big part of, the controls version of optimality.
Okay.
But I don't know how to see any consideration for energy usage from the robot or time,
Okay. Okay, I
and I
see.
would love to learn how to do that.
I see. I see.
Mhm. Okay. So there it is. There is the real robot performing as expected. Um, and that is most of what there is to show, but I've gone ahead and consolidated just of what I got from this course, what it was asking for, and what I appreciated about it.
Uh,
Um,
can you
Not to
just
go
refresh
and,
your
read out this essay.
Salvador? I was going to ask, can you just refresh your RV's window? It seems like it's lagging a little. Um,
My Arviz window.
oh no, the camera window, the one that was visualizing the robot doing the movement.
Oh, this one here. Okay. You want me to reload it, you said?
Yes, you just try to reload it, see
Okay.
if we can capture the replay.
Okay. Oh, I see. Yeah, this guy on the side is okay.
Yeah,
Is it okay? I didn't see any noticeable change when I reloaded.
oh, okay.
I noticed there was a play button here.
Right, right. Let me just hang on and I'll check something. All right. Don't worry about it. Let's get into your presentation. Then
Okay.
I will do a review to see what exactly was going on.
Okay. Sounds good. So yeah, I don't plan to go through the whole essay of what's here. Just wanted to do the main points of what we learned, which is how to actually build a map and using specifically these tools.
Right, right.
Some developing that understanding that you build a map and now it has to be accessible continuously. Having a whole server, a whole node which is in charge of each of these things, and how quickly this becomes a scaling problem with
Right.
multiple robots. Um, I would like to learn a little bit more about the different map configurations because this one uses LiDAR and odometry, but something I work with in my work is with sonar.
Okay.
And we don't have odometry for underwater robots. And so I'm interested in how can I build a map, a simulated map,
Right. That also makes
using
me.
different tools.
Yeah, it also makes me want to ask the question: how do you localize them? Right. It's an interesting question because you don't have the features, right, that we do use in either visual odometry or light odometry, right? They're not always there
No, yeah,
with.
it's different.
Yeah.
It's different. And my approach is also different because when I do it from my other perspective, I'm thinking I need to design a common filter, an extended common filter or an error filter.
Right.
My approach is different from how you guys do things, and I'm looking to merge those.
Right. Yeah. Yeah. The
Uh,
Kalman filter
and
is.
then, yeah.
I don't find it as something that you can avoid as long as you're doing advanced odometry. You will always need to learn about Kalman filters, right? It's just
Mhm.
for this, it's probably high up there. But also, the AMCL kinda does what the Kalman filter does, but just differently, right?
Yeah. Well, I guess I need to learn more about it.
Right.
To me, common filter is another control form,
Yes.
um, where instead of regulating a state error, I'm regulating a sensor error.
Oh, I
and
see.
and
I see.
that's my understanding of how common filters and common filter design, observer design, that's what that means to me.
Right.
But I've seen in other forms, for example, I've taken some MATLAB on-ramp courses and they say, oh, we'll use a common filter. And to me, it just looks like they're saying, oh, we assume that this is going to move in a straight line. And that's what the common filter is doing.
Right, right.
Very
And
different from
you also
what
do assume
my
the noise
personal
quality.
understanding of.
Yeah.
Exactly.
All
Yeah.
right.
I'm
Let's go.
thinking about things like how do I capture the noise, the spectrum density of noise so that I can use common techniques. Like it it's it's different.
Yeah, you want
It's
to
different. And I
understand
would like
why
to
are
learn
the
more about bridging
preconditions
that.
satisfied for the common filter, right? Yeah.
Exactly. Yeah, okay. So there's a lot of what was done here that I would like to explore more. And I think that would be really cool if they had like an advanced ROS course, or I'm sorry, an advanced navigation
Navigation
course,
course, yeah.
where they had maybe like case studies, you know?
Yeah,
Um,
we do have.
I think that would be cool.
It's just not available for certification yet, but it's there. It's available, yeah.
Oh, okay.
Yeah.
Okay.
We'll definitely get you to know when it's available.
Okay, appreciate that. Yeah, put me on the notification list. I like that.
Sure.
Okay. Um, So some comments about map building. Again, a lot of these things are kind of provided, but some lessons that I took and would probably share with others going through this is that you should be really careful when making your map,
Mm-hmm.
specifically on those like the minimum max distance ratings.
Mm-hmm.
They can create some confusion if you're like right up against the wall trying to make your map.
Mm-hmm.
Um, as well as the like empty value assumption.
Mm-hmm.
Those problems kind of take care of themselves mostly, but collision is definitely one of those things where if you bump into something, um, it will affect your map.
All right.
I know that there are tools like GIMP for like manually correcting stuff.
Mm-hmm.
I am not a fan of manually doing things,
Right.
especially as a controls engineer. My
Right.
perspective is, how can I make anything run on its own?
You'd rather
And
have a
so
system
this
take
is
care of that.
precisely. I'm what they my family calls me a yogi bear. I don't know if you're familiar with the reference, but it's this cartoon of this bear
I do know. I
with this
do know.
obsession of
Yes.
stealing. Exactly, right. It works so hard just to make something simple.
Right. Right. Anyway,
Uh-huh.
it's quite good to have that exploratory design in this particular context. I think. Yeah.
Mhm.
All right. Let's go on to
Yes.
any other bits you might want to talk about before we get into the question sections.
Okay, sounds good. Um, One other thing about this that I thought was important was the fact that uh, at first I thought I was going to make a map in the simulation and then make a map in the real map,
Mm-hmm.
and then with the real robot.
Mm-hmm.
Then I quickly realized that it was actually much better to do this in the simulation because we could like define landmarks.
Oh, okay.
The real
That's
map
interesting.
changes. Um, the obstacles from other people using them have things strewn about, and so if I tried to make the map that way, then what I would have had is landmarks where they shouldn't be.
Right. Right.
And despite the fact that we can do obstacle avoidance,
Mm-hmm.
which is a way to get around it, uh, my takeaway from this was if I'm able to have like some degree of certainty about what to expect for some things,
Mm-hmm.
I would do that in a simulated sense. And then for all what else is involved, I would rely on obstacle avoidance.
Right. Okay. That's a very interesting take. Because I would think if you have access to the real environment, wouldn't it be better to map using the real one? Um, or try to use maybe sim to real. Right. You get the closest mimicry of the environment done in simulation, and then you can know that when you are doing the real mapping, you're just correcting the errors that might have resulted from the mock-up that you do in simulation. That's like
Yeah, I
combining the
suppose that's
two. Yeah.
yeah. I think that's a better way of putting it.
Mm-hmm.
That like hybrid, like make the simulation as close as you can to the real thing. If I
Yeah. Yeah.
understood what you were saying correctly, make the
Yeah.
simulation as close as you can to the real thing.
Yeah.
Yeah, I do like that. But at least when I'm thinking about how to apply this, um, I'm like, for example, we have a Roomba,
Right.
and
The Hoover.
chairs are always moving, things are, and so if I had like a wall layout,
Yes.
those would be definite landmarks that it could use to localize. And instead of treating like um, a chair as a landmark, you could treat it as an obstacle, which would mean it
Oh,
doesn't like
I see what you mean. So your biggest choice for this comes from the fact that movable objects they are not reliable landmarks.
exactly.
Right.
That is precisely what I feel.
Right. Right.
And maybe it's wiser to do it your way. And I will develop that understanding as I get more practice. I only share that this is my current feeling of how I would do things.
Right. Right. Okay. It's all good.
And then again, nothing really new that I haven't already said so far.
Mm-hmm.
Um, and then, in case you were curious, I also had some videos of doing, building the map and then doing the pathfinding, but these are the simulation form.
Oh, it's good. It's good.
So yeah,
Show them to us. I
at this
think we've
point, I'm
got.
ready for any questions that you have.
All right. Questions. I think let's see your videos if you've got them, if they're quite close, because we've got 5 more minutes.
Okay. I think let's do building the map.
Mm-hmm.
I'll do this in ×2 speed.
All right.
It should take 3 minutes, but let's go ahead and skip ahead. So we can see here, things are just starting. Here I set up the RViz configuration. I show how to do that. I show the importance of setting, certain quality of service things. Oh, this was actually really helpful. Dealing with AMCL
Yeah.
and the quality of service, because in the ROS basics, we introduced reliability, or you guys introduced reliability. And I said, okay, I think I get that.
Right.
And then I had a whole problem with getting Spot Recorder to work because AMCL was not updating. And I thought this was a huge problem. I thought something was broken because it's not updating. And then I go and test it in the terminal and it echoes when I move it. And I'm like, okay, so it only updates when I move it.
Yeah.
Okay.
Yeah.
And then I realized, oh, there's a
Reliability.
durability setting that I
Incompatibility.
can do, which completely solves this complicated approach that I was trying to take, where I was going to say, send a spot, okay, move a tiny bit.
Yeah.
I'm
it's
so glad that I
it's
didn't end up doing that.
it's amazing how your face lights up when you speak about having discovered that it was quite simple.
I think that's a lot of engineering, is that like a lot of problem solving has been done for you.
Mm-hmm.
Um, and if you can cut down on custom things, then that's great.
That's great. Yeah.
Why reinvent? Yeah. Okay, so yeah, what's big around the background is that I just move around. Oh, I think something that I wanted to show. Oh, yeah, here it is. I changed the resolution because I wanted to have a very nice map.
Mm-hmm.
But I was, I don't quite know exactly where those limitations would start to come in of having like too big of a map file.
Okay.
But for this simple environment, for what we're doing,
I think it's all
seemed
about the
fine to
computational
me to
load.
make it even more fine.
Yeah, I think it's all about computational load. It depends with the hardware that you're running on your real robot, right? That's where
Yeah.
you're gonna get symptoms like penalty signs if there is any computational penalties that you're paying for the size of the map.
Interesting way of saying that. I don't know if this is what you meant, but what I got from that is that there's an interactive way of looking at the computational use of the map, and if it exceeds something, you could like uh, lower its resolution temporarily just to make it more. I don't know if that's what you meant, but that's what my first thought was when you said that.
Yeah, it's exactly what I meant. Because the thing is, everything that you get into memory, right, it will always
Mhm.
occupy some space. It will make your robot, or let's just say, make your system operate in a certain manner. If it needs to span another thread, it will probably need to do that, right? So everything comes down to like your real time performance. So that's what I was inkling towards. Yeah.
Mhm. Gotcha. Yeah. I think if I was having more experience with doing this with the real robot, um, then I think it would be interesting to see that
How
take
the
effect.
Yeah, I see. All right,
Mhm.
I think let's get into the questions now, Salvador. Unless you have something burning
Okay.
that you wanna speak about.
No, no, no. Please, please. I'm ready.
All right. You spoke about using some key players that do your, let's say, your local robot behavior management, right? And I'd like to ask you, what are those, and what default behaviors do you get out of the tool that you use to handle cases like obstacle avoidance and things?
Can you say your question again? I didn't quite catch all of it, but it sounds like you're talking about the way that we were interested in behaviors. So all of the configuration that we've done for um, like recovery and how do we do controlling and
Yes, I want to know, what tool do you use for your default behavior management, right? And what default behaviors do come available to you when you use that?
I don't think I'm understanding your question, actually. I'm sorry.
All right, no, it's fine.
You're asking what default tools do we use when doing the path planning?
No, when you're doing like, let's say your robot encounters an obstacle, right? What
Oh, uh-huh.
Yes, what behaviors does it resort to, and which
Oh,
part of
okay, I see. So how
yes,
do we do obstacle avoidance?
yes, or how do we manage
Gotcha. Okay, so my
occurrences?
understanding is that the task is split into a few different parts.
Mm-hmm.
We have the global planner,
Mm-hmm.
which uses where it believes it is on the global map,
Right.
uh, and it uses landmark distance, and it uses a scaling form, and it's called inflation, an inflation form of boundary setting. And so it uses that to come up with this like objective goal
Mm-hmm.
for the robot's, position to be at, and it comes with that plan.
Right.
Then there is another guy, this is the controller, which is doing this on a smaller scale. And what this does is it takes consideration of the sensor data
Mm-hmm.
and it creates a cost map for barriers that it knows about, barriers it does not know about.
Right.
And it readjusts how it plans based off of these new obstacles.
Okay.
Um, so this looks like this aura of increasing or of decreasing darkness from the obstacle. And so we can adjust those parameters by things like the size of the robot. It becomes a little bit more involved, which is kind of what I meant by a lot of these parts are trivialized by all of the tools that are given.
Right.
Um, but I don't think that takes away overall from the high level understanding of what's going on.
All right. Right. All right. All right. A very nice,
I
detailed
hope that
answer.
answers your question. Are there parts of your question that you feel are honest?
Yes, yes, you did answer them in a very detailed manner. Actually, you went beyond what I was asking, so that's good. Uh, can you hear me, Salvador?
Oh,
Oh, okay. Yeah, there you go.
okay. Whew.
All right. I think that's all of the questions that I had on this one, and very nice
Yes, I can hear
presentation.
you.
I really liked it. I really liked it. So what we'll do is we'll do a wrap up, and then we can continue meeting on Zoom. All right. All right, everyone. So
Sounds
that
good.
was
Thank you very
Salvador's.
much. Thank you all for watching my presentation.
Sure. Okay. So that was Salvador's sign off right there, and it was a very nice presentation. Congratulations to him for getting us in to understand what